Hey everybody, this is Mr. Ainsworth, and we are going to get into a little discussion here on odd and even functions. And I'm going to give Desmos a shot here. They have some cool animations, so hopefully this will help you out. So in the following slides here, we're going to be talking about symmetry and graphs. Okay, and the activity you'll observe that for some functions, when you look at them, it appears that they are the same on the left and the right of the y-axis. Okay, so if the y-axis is vertical here, all right, they're going to be the same on the left side of the y-axis and the same as the right side of the y-axis. If that's the case, you know they have that particular symmetry. You'll see that we're going to be calling them even. All right. For other graphs, it appears that they rotate about a special point called the origin, okay, where the two axes meet, right in the middle, 0, 0. However, most graphs do not appear to be either of these two types. And if that's the case, they're neither even nor odd. Okay, so even graphs, they are symmetrical about the y-axis. Okay, and if they are odd, okay, they're symmetrical about the origin, which means there's a rotational symmetry of 180 degrees about the origin, 0, 0. Or you can think of it as a double reflection too, a reflection over the x-axis and then the y-axis. So you'll see that. So let's see what we have here. So take a look at the graph here. Okay, so we have a graph of this polynomial function here. It doesn't matter what it is. But notice that the function of the graph on the left here, has symmetry about the y-axis, meaning that the y-axis here, this vertical axis that's been highlighted in orange right here, this graph has symmetry about that y-axis, meaning that the right half is symmetrical to the left half, which means they're basically the same. If you were to fold a piece of paper, if this was a piece of paper and foldable, and you folded it around or about the y-axis right here, the right half would overlap the left half, and we say that is symmetrical about the y-axis if that occurs. And if this happens, okay, we have what's called an even function. So let's tell you what, let's sorry about that. Let's screenshot this and let's take a look at, come on, there we go, at what we have here. Actually, let me try that again. There we go. All right, so let's grab a blank page here. Let's talk about symmetry about the y-axis. Let's talk about even functions here. So let's get some graph paper here, and let's paste this in and let's talk about it. Okay. So what am I talking about? So we have this y-axis here. So let's label a little bit here. We have this y-axis in orange. Okay, its y-axis is here. The x-axis is here. So the graph here, it's an even function. All right, and it's symmetrical about the y-axis. So take this point. Let's call this point A. It is roughly 2 and a little bit, maybe, I don't know, over 2 units to the right of the y-axis right here. That's the distance I'm talking about here. If you reflect that to the other side across the y-axis, you get to this point, call it A prime. Okay? So this point or every point on the graph, I'm going to call this function f, let's say, is reflected across the y-axis. Okay? It's called a reflection, okay, across or over what's called the y-axis. Okay, so for example, this point right here happens to be 3, 0. Let's call this point B. Okay, so this point is 3, 0. This is on the x-axis, right? So it's got to be 3, 0. It gets reflected onto the other side, right over here to this point, B prime. Okay, and notice that it's at negative 3, 0. Okay, so any point that has, or any function that's even, okay, has y-axis symmetry. Y-axis symmetry, and algebraically speaking, okay, you're talking about any point. This is weird. I don't know why this is happening right here. But anyways, any point A, comma B, gets reflected across the y-axis, what happens is you take the opposite of a, comma b, and that's algebraically what happens. So at this point here, 3, 0, we're talking about b at 3, 0 here, gets reflected to b prime to the opposite of a, which is the opposite of 3, which happens to be negative 3. Opposite of 0 is 0. Okay, and any function that is even gets reflected across. So if it's on the right 3 units of the y-axis, it gets reflected to the left 3 units on the y-axis. Okay, and then if it's translated up and down, then that happens too. So let's take a different point here. I don't know why this is happening here. So let's take this point here. Not B. Let's call it something different here. C, let's say. Okay, so this point right here is 3.5, 3.5, comma 4. So 3.5, comma 4. Okay, so notice that it gets reflected way over here. Okay, notice that it's at negative 3.5, comma 4. So C prime is at negative 3.5, comma 4. Same distance but opposite side. Same distance from the y-axis, that is. Same distance, comma, opposite side. Now, because it's on the opposite side, the x-coordinate changes sign, and that's why a, comma, b goes from there to negative a, or the opposite of a, comma, b, because it's on the opposite side. Keyword opposite, all right? Same distance, opposite side. So a goes to negative a, and b, well, b doesn't change because the height doesn't change, right? Like c went to c prime, they're both 4 units up. So the y-coordinate doesn't change, only the x-coordinate. Okay, only the x-coordinate. And so that's a quality of even functions. They all have y-axis symmetry. Let's go back to Desmos here, and let's check out a couple different functions. So here we have many different functions here. Let me zoom out here a little bit so you can see the graphs. So we have 4 graphs here. It says look at all these functions. Only the red and blue ones are even. Okay, and because the y-axis acts like a mirror, so that they are the same on the left and the right of the y-axis. Well, let's go ahead and analyze this. Okay, so let me just bring these functions in. All right, so check this out. So we have these functions here, and only it says here only the red and blue ones are even. Okay, so this one's even. Okay, this one's even. And the other ones, well, they're neither, right? So not even, so neither. Or let's just say not even, okay? So not even. We'll talk about why here in a minute. So not even, and this one here, not even. It says only the red and the blue, okay? So graph number 1 and graph number 2, graphs number 3 and 4 are not even. Why? Because they are not symmetrical about the y-axis. Okay, so let's analyze this here. So this point right here looks like 2, 4. So A is at 2, 4. Okay, and it gets reflected across the y-axis to this point right here, which happens to be negative 2, 4. Why? Because it's left 2 units down 4 units. I'm sorry, that's negative 4. Sorry, 2, negative 4. Okay, so it's the same distance, opposite side. So the y-axis here, right in through the middle here. Let me highlight it. Okay, so it's symmetrical about this y-axis right here. Same distance, opposite side. So notice that it says that the y-axis acts like a mirror. So the right side is symmetrical to the left side. So look at this point right here. Let's call it B right here. This B is 3, 5. All right. If you're going to reflect it, it's the same distance on opposite side. So it's 3 units away on the other side. So B prime right here should be at negative 3, 5. Notice that only the x-coordinate changed, not the y-coordinate. So for even functions, all right, for even functions, any point, x, y, gets reflected across the axis. So you take the opposite of x, y. Notice the y-coordinate did not change. And I used a and b last time, so it's the same thing as this. So any point a, b gets reflected across the y-axis, becomes opposite of a, b. Okay, no mysterious right there. Only the a value changes in opposite sign. Only the first coordinate. Okay, if you're going to be on the opposite side, you got to take the opposite in sign, right? So instead of positive 3, it becomes negative 3. Instead of positive 2, it becomes negative 2. It's that simple. The y coordinates do not change. The same thing here. Let's take this point. Let's call it C. Now this one looks like it's right 2 up 3. So C is 2 comma 3. Man, my digital pen is not doing well. Excuse me for a second. I love digital technology. Now, if you reflect this on the opposite side, there are going to be 2 units on the left side, okay? And right there, it goes to C prime. And if you're on the left side of the y-axis, well, the x value has to be negative. So negative 2 comma 3. Okay, so there you go. It's that simple. And if you want to zoom in here, let's take a look at some other points. Some nice, easy points to work with here. We don't have any nice and easy points to work with here. Let's see. These are all decimal values. Okay, so I'm going to estimate here. So let's call this point D. Now it's a little bit to the right of 2. So let's say it's 2.1. So 2.1 comma 0. You reflect that onto the opposite side. Okay, to D prime. Guess what? You're at negative 2.1 comma 0. So negative 2.1. Oops. Excuse me. Negative 2.1 comma 0. Same distance, opposite side. Okay, and that's what even functions are all about. All right, they have symmetry about the y-axis. And to notice that, every point is the same distance, all right, from the y-axis, but on the opposite side. And that's why the points, when you reflect them across the y-axis, a comma b becomes the opposite of a comma b because it's on the opposite side. This symbol right here is the negative symbol, but it's referred to as the opposite, okay? All right. And then when you go on the opposite side of the y-axis, it changes sign. The y-coordinate doesn't change at all, only the x-coordinate or the first coordinate, okay? Now, the other graphs are not even. They don't have symmetry because at this point right here, let's call it D, all right? That's 2 comma 0. Now, if you reflect that, it goes over here. And obviously, the low point, this low point right here, that's not at negative 2 comma 0. This is not negative 2 comma 0. It should be obvious. All right. So this is not symmetrical, okay, about the y-axis. And because of that, it's not even. And so what you're supposed to do is you're supposed to learn from these graphs right here in this lesson what are symmetrical about the y-axis, which means which ones are even and which ones are not. Now, some functions do not behave like that. Like this one is not symmetrical about the y-axis. It's symmetrical about the origin, which means it has a 180-degree rotational symmetry about the origin, which happens to be at 0 comma 0. So what in the world does that mean? Okay, so let's oops, sorry. Let me grab this here and let's talk about it. All right. Okay, so what does it mean to be odd? What does it mean to have rotational symmetry about the origin? Well, rotational symmetry. So functions that are odd, these are odd functions, have 180-degree rotation about the origin, which happens to be 0 comma 0. So this point right here, call it A on the graph. If you want to rotate it 180 degrees, it will rotate up here. So any point in quadrant 4 will appear in quadrant 2. By the way, this is quadrant 1, this is quadrant 2, quadrant 3. Okay, Q3 is called quadrant 3. And then quadrant 4. You guys should already know that from Algebra 1. So A gets rotated to what's called A prime. So if this was, let's say, 1 comma, I'm going to just guess here, 1 comma, it looks like it's down 1.5 units, so negative 1.5. Then you take the opposite of both of these and you get the A prime. So you're left negative 1 and up 1.5. So negative 1 comma 1.5, and that'd be A prime. So in terms of odd functions, okay, which all have symmetry about the rotational, we'll call it rotational symmetry. I don't know why my pen is off. Rotational symmetry about the origin, which happens to be 0 comma 0. Okay, any point x comma y gets rotated to negative x comma negative y. It happens to be a double reflection over both axes. Okay, so you change the sign of both coordinates. That's all you do. So change sign of both coordinates. That's all you do. So if I had a point on the graph, let's say it's a1 comma negative 1.5, you change both signs. Well, what's positive becomes negative, and what's negative becomes positive. So it gets rotated to negative 1 comma 1.5, which happens to be up here in quadrant 2. And that happens anytime you have a point on the graph. So let's take another point. Let's take this point right here. Okay, B. Now B looks like it's negative 1.5 comma negative 1. So negative 1.5 comma negative 1. Notice that they're both negative. And it better get reflected over here 180 degrees. So anything quadrant 3 gets to quadrant 1, or it gets rotated to quadrant 1 because it's a 180 degree rotation. All right, and you change the sign of both coordinates here, so both become positive. 1.5 comma positive 1. In other words, the point that I picked on the function negative 1.5 comma negative 1 gets rotated to B prime, changes both signs to positive 1.5 comma 1, which happens to be in quadrant 1. So if you start off with any point in quadrant 3, it gets rotated to quadrant 1. Any point that starts off in quadrant 4, all right, goes to quadrant 2. All right, why? Because it's 180 degree rotational symmetry about the origin, and that always happens in a graph, if it's odd, that is. Okay, so this is odd functions only. So let's see what's going on in the next ones here. So what kind of symmetry does this have? What do you think? Okay, say it out loud. What do you think? Odd or even? Does it have y-axis symmetry, or does it have x-axis symmetry? Excuse me, rotational symmetry. So it says over here, click on the gray circle if you think it's symmetrical about the y-axis. Okay, so at this point here, 2 comma 5. Well, look over here, if you fold the paper along the y-axis right here, okay, it goes right over here to negative 2 comma 5. So this one here, notice it has y-axis symmetry. All right, if you fold the right half, it will line up with the left half, or vice versa. Now it does not have rotational symmetry. If you rotate this, 2 comma 5 will go down here in quadrant 3 to negative 2 comma negative 5. Okay, it will go downward instead of upward, because if you rotate 180 degrees about the origin, it will face downward instead of upward. So this graph does not have rotational symmetry. It's not odd. It happens to be even. Okay, so let's screenshot this guy. Let me just bring this in just so you can see it, so we can talk about it here. All right, so what was I saying? So this point here, this one's even, okay? Why? Because it has y-axis symmetry. It's symmetric about the y-axis, which is this orange line right here. So this point right here, A, which happens to be 2 comma 5, 2 comma 5, it gets reflected to this point right here, A prime, which happens to be negative 2 comma 5, negative 2 comma 5. Notice that only the x-coordinate changed. So any function that's even, and I've said this multiple times, but I'll say it again, any point x comma y goes to the opposite of x comma y. Notice that we take the opposite of the x-coordinate, not the y-coordinate, because it doesn't change height. It only goes to the opposite side, and it has to change sign. So only the x-coordinate changes. Change the sign of the x-coordinate. Change the sign of the x-coordinate only. Now, I've said that multiple times already, but that's exactly what happens. All right? And this point right here, I don't know what it is. B gets reflected to this point right here, B prime, because it has y-axis symmetry. We went over this in geometry a couple years ago. All right, and now we're revisiting it again, but now all we're doing is we're calling it even. Okay, so even functions just have y-axis symmetry. All right, let's go check out the next one here. So does this have y-axis symmetry? Well, let's take a look. All right, let's just grab this this function right here. And let's just take a peek at it and let's analyze it, okay? And to analyze it, well, you just pick a point on it. Okay, so let's pick a point. Let's pick this high point right here, this relative max. So this point right here, A. Now, if I was going to reflect this, it's about a little over 3 units on the right. If I was going to reflect it on the left, it'd be over here. Okay, but there's no point on the graph. Okay, over there. So the graph's way over here. So that's A prime is not even the graph. So the y-axis, which I'm highlighting right here. Okay, so this graph does not have y-axis symmetry. This graph does not have y-axis symmetry. Okay, so I can say that it's not even. Okay, now so this point right here that I picked, it looks like about 3.1 comma 2. So 3.1 comma 2, I don't know, I'm guessing right there. Now if I was going to take the opposite of both of those signs, if I took A, which is, I picked it to be 3.1 comma 2, and I took the opposite of both of those, I would get negative 3.1 comma negative 2, and that happens to be, well, not negative 3.1, I gotta back up here, guys, sorry. Gotta look at the scale, alright? Sorry, that was bad by Mr. Ainsworth, okay? Okay, so this is 1, this is 1.5. So maybe this is 1.6. So 1.6 comma maybe, I don't know, it's definitely 2 because it's 2 units high. So let me redo this one here. 1.6. Actually, I plotted it correctly here. So I just didn't write down the coordinates correctly. So if I was going to take A, which is 1.6 comma 2, now that I got that right, and I take the opposite of both of them, all right, so I take the opposite of 1.6 and the opposite of 2, and I plotted that, I go left 1.6 and then down 2, it'd be right here. Holy cow, we'll call this the A double prime. All right, and when that happens, when you take any point and you take the opposite of both coordinates, opposite of x and the opposite of y, you have an odd function, okay? And what's happening is that it's a rotation, okay? A rotation of 180 degrees about this point, which is called 0, or what's called the origin. Okay, it happens to be a double reflection. Reflect over the x-axis and then the y-axis. Okay, you can do it that way as well, by the way. Okay, so a 180 degree rotation is the same as a double reflection over the x and y axes. And any point in quadrant 1 goes to quadrant 3 and vice versa. And any point in quadrant 2 goes to 4, and any point in quadrant 4 goes to 2, and etc. Okay, so this is an example of an odd function which has symmetry, rotational symmetry, 180 degree rotational symmetry, okay, about the special point called the origin, 0, 0. All right, now let's take a look at the other functions they have here in Desmos. So this one here, so what kind of symmetry does this have? What do you think? Does it have y-axis symmetry, or does it have rotational symmetry? Is it even or is it odd? Okay, so say it. So on this one here, let's go ahead and you already have your opinion. So let's just grab this function here. Actually, let me change that. No, that's fine. Let me bring that into our discussion here. All right, so on this one here, let's pick a point. Okay, and so these are going to be decimal values, but that's okay. So let's pick this relative max right here. So let's call this point A. So it looks like a little bit less than -1. So 0.9 comma 1. No, this is 1 and this is 0.5. So this is about 0.9, negative 0.9 comma 0.5. Okay, because you don't go left 1 unit. So I picked a decimal to the left of -1, like -0.9. All right, now if you're going to reflect it across the y-axis, this vertical axis right here, it gets reflected right over here, okay, to A prime, which happens to be, it's a little bit less than 1 again. So if this is 1, that's about 0.9, and you're at the same height, 0.5. So notice that this point, call it x comma y, got reflected to negative x comma y. Okay, we took the opposite in sign. Notice only the x-coordinate changed in opposite sign. It went negative 9/10 to 9/10. The y-coordinate did not change. All right, and because of that, my friends, this is called an even function. All right, because it's symmetric about y-axis. Okay? Okay. All right, what's next? Let's take a look at this one. Now, this one. Is this odd or even? Does this have symmetry above the y-axis or above the x-axis? Let's find out. Okay. So let's analyze this. So what you do is you pick a point, like this point right here, the relative max, A. I just call it A just for funsies here. All right, and it's about, I don't know, if this is -1, this is -1.5, so this is about -1.8. So -1.8, comma, and it looks like maybe about 1.8. Okay, don't know what it is, but that's an approximate. Now, if I was going to reflect that, go the same distance on opposite side, okay, it would be right about here. Okay, this would be A prime. All right, so it's not symmetrical about the y-axis. So definitely not symmetrical about y-axis, okay? And because of that, it's not even. Okay? Okay. Now, if you pick another point, or keep the same point here, okay? So if it's odd, okay? So if odd, meaning if it's symmetrical about, let's say, the origin, excuse me, a point in quadrant 2 would appear in quadrant 3, and this graph is not in quadrant 3, so it's definitely not odd. Okay, but the way algebraically here, and if it's odd, x comma y gets reflected, or rotated actually, to negative x comma negative y, and so I took this point A, which is -1.8 comma 1.8. Now, if you take the opposite of both, you get 1.8 comma -1.8, right? You got to take the opposite of both of them, right? And this right here is in quadrant 4. So we start off with quadrant 3, you get a point in quadrant 4. You go right 1.8 and then down, you're in quadrant 4. And the graph does not exist in quadrant 4. I'm sorry, quadrant 4 is down here. So this is quadrant 1, quadrant 2, quadrant 3. All right, over here is quadrant 4. And so because the graph doesn't exist in quadrant 4, well, it can't be odd. So this is not odd. Okay, so it's not odd, it's not even, it's neither. Why? Because this portion right here that I'm highlighting right here is different than this portion right here. They're not the same. They're not reflections or mirrors of one another, okay? Not the same. Hopefully you guys can see that now. Okay. A little bit more here. That's about the same. Okay, so on this one here, is it odd, even, or neither? What do you think? So let's just take a look at it and analyze it. So right now you should be thinking something. Okay? So what are you thinking? Is it odd, even, or neither? So what type of symmetry does it have? Is it symmetrical about the y-axis? You should say something right now. Make a decision. Okay, so right here, this point, let's call it A. It's at -2 comma 1, -2 comma 1. If I was going to reflect it, it would be over here at 2 comma 1. So here's A prime at 2 comma 1. So it's not even. Okay, it's not even. Not symmetrical about the y-axis. Okay? And then is it odd? Well, if you take the opposite of both of those two coordinates right here, so A is at -2 comma 1, and you take the opposite of both, it transforms to A prime, which is 2 comma -1, and 2 comma -1's down here. We'll call it A double prime. All right, A double prime's there. And guess what? That graph, that's not on the graph right here. So it cannot be odd either. So it's not odd either. It's neither. So it's not even and it's not odd. So we say it's neither. Okay? So you select neither. And that's the basic idea. And so you just want to play with it and get used to it. And hopefully this little demo here, what it means to be odd and what it means to be even in just terms of symmetry, helps you guys out. Okay? So this Mr. Ainsworth here, and just a little teeny video that I thought about when I was thinking about you guys. I haven't been with you in a while because I have some major serious family issues going on, so I apologize for that. But hopefully this helped you out understand odd and even functions. Okay, and I will see you in my next lesson. Take care. Bye-bye.